Numerical integration. Let's recall first. We know that if f(x) is a non-negative function on the interval ab, then the area of the region under the graph y equals fx between x equals a and x equals b is given by the definite integral, the integral between ab of fx dx. It is possible to approximate a given definite integral using sums of areas of rectangles under the curve y equals fx, as we did before with the Riemann sum. We will learn more methods to approximate a given definite integral using sums of areas under the curve y equals fx. We will focus on the theoretical side of the subject. Recall. Here is approximation of the area under the graph y equals fx on the interval ab using n subintervals. The length of each subintervals is delta x, which is also b minus a over n. Let's choose the points in each subinterval for the height to be the left-hand endpoints. We get this one for the first, and here is the second, and here is the last one. And the approximated area is the sum of those areas, which is the width, which is equal to each one, times the sum of the heights of each one of those rectangles. The width is delta x, and the sum of the height is f of a plus delta x plus f of a plus n minus 1 delta x. Now we are going to estimate the area, but this time we are taking the height to be the value of the function at the right-hand endpoints. Here's the first one, second one, the one before the last one, and the last one. And the approximated area now is the width times the sum of the heights. In this case, the heights are starting, because it's a right-hand point, with f of a plus delta x, and the last one is f of b, as you can see. Let's now write the approximation using the height of the function to be the left-hand endpoint as before. We have that. Let's now add them up. On one hand, we get 2a's. On the other hand, we get delta x times f of a plus 2 times f of each one of a plus whatever delta x except the last one, which is f of b. It means that another way actually to approximate the area is by averaging the right and the left Riemann sums, and we get delta x over 2 times f of a plus 2 times f of a plus delta x plus 2 times f of a plus 2 delta x plus 2 times f of a plus n minus 1 delta x plus fb. This is the trapezoidal rule. Observe that except from fa and fb, all the other ones are multiplied by 2. The trapezoidal rule is just the average of the right and the left Riemann sums. Now let's use the fact that the trapezoidal rule is the average of right and the left Riemann sums to write it a little in a different way, because the name really does not suggest average, but suggests that this has something to do with trapezoids. So this is the trapezoidal rule. Instead of writing 2 times f of something, I'm writing twice f of something plus f of something. So instead of this, I'm writing this. And I'm doing this to all those guys. Now, this equals to this. So it is really exactly the same as above. But now I'm going to focus on each one of those parts here. What is this? This is exactly the area of this trapezoid. Let's see. The sum of the base of this trapezoid is FA plus f of a plus delta x. And the height is delta x. And the area of a trapezoid is the sum of the bases times the height over 2. So indeed, this is the area of the first trapezoid. This is the area of the second trapezoid. And this is the area of the last one. The area of each one of the trapezoid is delta x over 2 times the sum of the bases, which is always f of a plus I minus 1 delta x plus f of a plus I delta x. It means that this is really approximating the area by summing the area of n trapezoids. And that's why it can also be written as such. So if I related this as a trapezoid, then this is the sum I runs from 1 to n of delta x f of a plus I minus 1 delta x plus f of a plus I delta x over 2, which is just each one of those guys, the area of a trapezoid. Here is the official trapezoid rule. The integral between a, b, f, x, dx can be approximated by t sub n, which means that there are n subdivisions, which is also delta x over 2 times fa plus 2 fa plus delta x plus 2 times f of a plus n minus 1 delta x plus fb. And delta x is b minus a over n. Example. Let's use the trapezoidal rules with n equals 6 to approximate the integral between 1 and 4 of fx dx. Delta x is b minus a over n, which is 1/2. And in this case, we even don't have the function, but we don't need to do actually the graph of the function. We don't care about what function is this as long as it is continuous function. So we will assume it is continuous function. And we are going to do like we did approximation for Riemann sum. We will try to do most of the analysis on the x-axis. We will divide to 6 subintervals between 1 and 4 by taking increments of 1 over 2. We can count. We have indeed 6 subintervals. The ones that are highlighted with blue are going to sum only 1 time. And the guys with the yellow are going to be summed 2 times. And we get that.